Hello everyone. This video lesson is on limits involving infinity. Now this time I'm not adding my face in this video because I'm wondering if it's my face that is making the upload process taking so long. And so I'm going to see if I don't put my picture in the corner, if it will upload a lot faster. Today we're talking about limits involving infinity. We're also going to touch on the ideas of end behavior and horizontal asymptotes. Right now, you're probably only really familiar with horizontal asymptotes, but by the end of this video lesson, you should have some familiarity with limits and limits involving infinity and also the idea of end behavior. Let me start off with an example first. Let's say I have a function f of x equals x squared. The question that we are interested in when we think about end behavior is this. What is happening in the far right and far left of the graph? Okay, so let's look at this graph right here. F of x equals x squared. We all know how it looks like. It's a parabola that faces up and it goes like this. Okay, now what we're going to do is we're going to kind of ignore what happens in this middle portion of the graph, and instead we're going to look at the far right of the graph. Now you can see that the far right of the graph involves the parabola, the graph, going higher and higher and higher. This is confirmed by if we made a table. If I have an x column and an f of x column. If x is 0, f of x is 0. If x is 1, f of 1 is 1. If x is 2, f of x is 4. If x is 3, we have an output of 9. Input of 4 is 6, gives us an output of 16. Input of 5 gives us an output of 25. Now, as you can see, as these x values get higher, so do the y values. What if I skip a whole bunch of inputs and go all the way to 100? Then the output will be 10,000. If I go 1,000, then the output will be 1 million. And so what is happening is that as x gets large, f of x, the y values, also get really large. So this is how we would think about it. We would say, okay, as x gets larger and larger, the y values get larger and larger. In fact, if x were to approach infinity, then the y values will also approach infinity. Graphically, what's happening is that as x gets super, super large, the y values also get super, super large. So the graph is going up forever. That is the graphical interpretation. So what is happening at the far right of this graph? What is the end behavior on the right-hand side? The end behavior is that the y values are getting really large. It's approaching infinity. And so here's how we write it as in symbols. We write LIM, which stands for the word limit. On the bottom of LIM, we write x arrow infinity. What that is illustrating is that we want x to approach infinity, or for x to get really, really, really large. Next to this, we write f of x, the name of the function, and then we write equals, and then infinity. What is the verbal way of saying this line? We're saying as x approaches infinity, y approaches infinity. Okay, so that's what that is saying. Now what about on the far left of the graph? Now I'm going to get rid of this table so that there's room. What happened to the far left of this graph? Well, we can see that as x approaches negative infinity, meaning as x gets really super negative, the y values approach infinity also. So the graph is also getting higher and higher as you move from right to left. And so how do we write this as a limit? We write LIM. Underneath that we write x approaches negative infinity because we want the x values to get super negative. Next to it we write f of x. And what are the y values approaching? It's also positive infinity like the other one. Okay? And so both limits, the far right extreme and the far left extreme of the graph, both limits equal infinity because on both ends of the graph, the y values are approaching infinity. The y values are getting really big, really positive. Okay? More and more, it's getting larger and larger in the positive direction. Okay? All right, let's do another example. This time we're going to do f of x equals 1 over x. Okay? Well, first of all, let's graph it because that would be helpful. It's always easy to just look at the graph when we talk about end behavior. Okay? So end behavior. So we're going to write end behavior, and we're going to describe end behavior using that limit notation that we just went over. So we ask ourselves the limit as x approaches infinity of this function equals. Okay? So we're asking what is happening to the y values as the x values get larger and larger. Well, for this x value right here, this right here is the y value. For this x value right here, this right here is the y value. For this x value, the y value is over here. So it appears that as x gets larger, the y values, the output of those x values, are getting smaller and smaller. In fact, they're getting closer and closer to 0. And if you look at the graph, indeed, the graph is getting closer and closer to the x-axis. So what y value are we getting closer and closer to as x gets larger? We're approaching a y value of 0. So we write 0 over here. Okay? We write 0 right there. And the reason is because the y values are approaching 0. It will never be 0 because the graph will never touch the x-axis, but we're approaching it. And that's the idea of limits. What y value are we getting closer and closer to? And and the answer is 0. Okay? Let's look at the far left extreme of the graph. Well, if I have this blue point right there, this is the x coordinate, and this right here is the y coordinate. If I go this way, this x coordinate gives you an output of this y coordinate. If I go over here, then this x coordinate gives us this y coordinate. So it appears that the y coordinates, these blue ones, are also approaching 0, but from the negative side. So we write the limit as x approaches negative infinity, f of x equals 0 also. As x approaches negative infinity, in other words, as x gets super small, small as in super negative, the y values approach 0. Okay? Now, what you also notice is that if our limit, our end behavior limits are equal to a certain number, then that number is also our horizontal asymptote. So, is there a horizontal asymptote for this graph? And yes, there is. It is this right there, what I'm doing as a dotted line. That is a horizontal asymptote. And so what is the equation of that horizontal asymptote? It is y equals 0. Notice that it matches this. This horizontal asymptote matches the two end behavior limits. Okay? All right. So to end, I'm going to give you a couple problems that I want you to try on your notes. And then in class, I will be checking that you have these functions on your paper. Okay? Example 1. Okay? So find, or not find, let's say we will not find, give the end behavior the first one is f of x equals 3x plus 1. The second one will be f of x equals negative x cubed plus 2x squared. The third one will be f of x equals e to the x. And the fourth one will be f of x equals x squared minus 1 over x squared plus 1. And finally, the last one is f of x equals 2x squared minus 1 over x squared. Okay? So what do I want you to do for each of these? I want you to figure out the end behavior limits. Tell me what x, the limit as x approaches infinity is, and tell me what x, the limit as x approaches negative infinity is. And if there is a horizontal asymptote, give the equation of the horizontal asymptote. If you don't know how these graphs look like, how these functions look like, then graph it on your graphing calculator and use that graph to help you determine these end behavior limits. That's all, folks.